Okay, let's take a look at something that's a little bit different than what we've been looking at. Here we see no balanced chemical equation, so I know that this is a molar conversion, and we're going to follow the same steps though. We're going to write down what's given, and then we are going to cancel out our units, see what we got. So in this one, we're given 11.2 grams of CO2. So let's start by writing down 11.2 grams of CO2, and it is asking us how many molecules are present in that. So I'm going to write down molecules. Okay, so here we are, and I'm going to draw my T-chart. Think about the conversion factors you have. The first conversion factor we talked about is that 1 mole of anything equals the value 6.022 times 10 to the 23rd. And we said that typically in chemistry that is referring to atoms, particles, or molecules. The second conversion factor that we said is 1 mole equals grams, and this was the molar mass. Okay, and the third one that we've talked about is mole ratio, which we don't even need because there's no two substances. We're staying within the same substance, so there's no reason to use this conversion factor. Let's start by doing what we always do, and that's by dropping down our units. So we're going to drop down grams of CO2. And currently, we don't have a direct conversion factor. Some of you look at this and can see something, and I know you can see that, but let's kind of hold on that for right now. And let's get rid of this grams of CO2. When we see grams, we're looking for a molar mass. So find your molar mass of CO2. When you do that, you're going to see that's 44.009 grams. And guys, think about what does that number mean? That number represents 1 mole. Okay, so we've got 1 mole of CO2. Now grams of CO2 is canceled out. I'm at moles of CO2. Trying to get to molecules, so I need to drop down moles of CO2. Because again, I want these two things to go away. Well, look right here at your very first conversion factor. 1 mole represents 6.022 times 10 to the 23rd molecules. And this is where a lot of you messed up on this problem, was how you put it into your calculator. When you put this in your calculator, you've got to put everything up top, and even this right here in parentheses, and then divide by the 44.09. So go ahead and try putting that in your calculator, please, and let's see what we get. And what I am getting, where is this thing, is 1.53255 e to the 23rd. And that e to the 23rd is at the very end of the calculator, so you got to pay attention to that. That e to the 23rd means times 10 to the 23rd. So my actual answer would look like that, and that is in molecules. Notice that what I was given in the original was 3 significant figures, and here I also have 3 significant figures. So my final answer would be 1.53 times 10 to the 23rd molecules. And you all really struggled with knowing when to use that value, and I'm telling you, the only time you're going to use that value is when you see the word molecules or atoms.